Preparing for a Datadog Solutions Engineer interview questions and answers interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you explain Datadog's observability platform to a customer evaluating it? I describe Datadog as a unified platform for understanding what applications and infrastructure are doing, why they behave that way, and how users are affected. Metrics show trends, logs provide detailed events, and traces connect latency across services. I would first learn the customer's environment and incident challenges, then demonstrate a relevant workflow rather than list features. The value is faster detection, shorter troubleshooting, and better collaboration across development, operations, and security teams. While answering, define observability, connect metrics, logs, and traces, explain unified visibility, emphasize business outcomes, and tailor the explanation to the customer's architecture, operational maturity, and specific pain points. Question 2. How would you conduct technical discovery with a prospective Datadog customer? I begin with outcomes. What incidents are most expensive, which services are business critical, and how success will be measured. Then I map the architecture, deployment model, cloud providers, languages, telemetry sources, and existing tools. I ask how teams detect, investigate, and communicate during incidents. Finally, I identify technical owners, security requirements, timeline, and evaluation criteria. This prevents a generic demo and lets me build a focused proof of value around measurable customer problems. Make sure to cover business goals, architecture, telemetry sources, current tooling, incident workflows, stakeholders, success criteria, constraints, and thoughtful follow-up questions that uncover both explicit requirements and hidden operational problems. Question 3. What is the difference between metrics, logs, and distributed traces, and when would you use each? Metrics are numerical time series, ideal for detecting trends, saturation, and alert conditions. Logs are timestamped events containing detailed context, such as an exception or user identifier. Traces follow a request across services and expose latency, dependencies, and errors. During an outage, I might detect rising latency through metrics, inspect logs for the failure message, and use a trace to identify the slow downstream service. The strongest investigation correlates all three signals instead of treating them separately. In your answer, distinguish aggregation, event detail, and request context. Discuss cardinality, storage, query patterns, correlation, and examples showing how the three signals work together during an investigation. Question 4. How would you design a Datadog monitoring strategy for a microservices application? I would start by inventorying services, owners, dependencies, and critical user journeys. For each service, I would monitor latency, traffic, errors, and saturation, then add infrastructure health, database capacity, queue depth, and deployment events. Distributed tracing would connect symptoms to dependencies. Alerts should represent actionable customer impact, include ownership and runbook links, and use appropriate evaluation windows. I would review alert quality regularly, because an impressive dashboard is useless if engineers ignore noisy notifications. Be sure to mention service inventory, golden signals, infrastructure and dependency monitoring, ownership, dashboards, actionable alerts, tracing, deployment events, and avoiding noisy monitors through clear thresholds and priorities. Question 5. A customer reports high application latency but their infrastructure metrics look normal. How would you troubleshoot it? First, I would confirm where latency is measured: browser, API gateway, service, or database. Normal host metrics do not rule out slow code or a dependency bottleneck. I would inspect distributed traces for span-level timing, compare successful and failed requests, review database query performance, and correlate logs with deployments or configuration changes. I would also verify instrumentation and sampling, since missing spans can mislead us. The goal is to isolate the slow segment before proposing remediation. Focus on validating the symptom, comparing client and server latency, examining traces, dependency timing, logs, database queries, recent changes, sampling, and distinguishing monitoring gaps from genuine application behavior. Question 6. How would you explain and implement Datadog monitors without creating alert fatigue? I treat every alert as an invitation to take a specific action. I would begin with customer-impacting symptoms, define a meaningful threshold and evaluation window, assign ownership, and include context and a runbook. Anomaly detection can help with changing baselines, while composite monitors reduce noise when several signals describe one incident. I would separate warning from critical severity and review notification history after launch. A monitor that pages repeatedly without useful action should be redesigned or removed. Mention actionable conditions, symptom-based alerting, thresholds, evaluation windows, anomaly detection, composite monitors, severity, ownership, notification routing, recovery messages, and regular review of false positives. Question 7. What are SLOs, SLIs, and error budgets, and how would you use them with Datadog? An SLI measures an aspect of service performance, such as successful requests or acceptable latency. An SLO sets the desired reliability target, and the error budget is the permitted unreliability over that period. In Datadog, I would build service-level indicators, track SLO compliance, and alert on rapid or sustained budget burn. This shifts discussions from arbitrary infrastructure thresholds to user impact. If a team exhausts its budget, it should prioritize reliability work before adding risky features. In your answer, define each term, connect SLIs to user experience, explain error budget calculation and burn rates, and show how SLOs guide alerting, prioritization, and release decisions. Question 8. How would you instrument a new service using Datadog and OpenTelemetry? I would first choose the supported language instrumentation and enable automatic instrumentation for common frameworks, databases, and HTTP clients. I would add manual spans around important business operations that automatic hooks miss. Telemetry should carry consistent service, environment, and version attributes, with context propagation across requests. I would deploy the Datadog Agent or an OpenTelemetry collector, configure sampling and data controls, then validate traces through a representative workflow. Instrumentation should reveal useful behavior without exposing sensitive payloads. Cover automatic versus manual instrumentation, language support, agent or collector deployment, resource attributes, propagation, sampling, sensitive data controls, validation, and consistent service naming across environments. Question 9. How would you troubleshoot a Datadog agent that is not reporting data? I would isolate the problem from the host outward. First, I would check agent status and logs, confirm the API key and site, and run the agent connectivity diagnostic. Next, I would verify DNS, proxy, firewall, TLS, and outbound access to Datadog endpoints. I would inspect integration configuration, permissions, container mounts, and environment variables. Finally, I would confirm expected tags and timestamps in the UI. This sequence distinguishes authentication, transport, configuration, and visualization issues quickly. Be sure to discuss agent status, logs, connectivity, API keys, permissions, proxy and firewall settings, host tags, integration configuration, container behavior, and a systematic isolation process. Question 10. How would you approach a customer concerned about Datadog observability costs? I would treat cost as an engineering design problem, not simply recommend deleting data. I would identify the main drivers, such as indexed logs, custom metric cardinality, trace volume, retention, or duplicate telemetry. Then I would separate data needed for real-time detection from data useful for investigation or compliance, applying sampling, exclusion filters, shorter retention, and better tag discipline where appropriate. I would preserve critical signals and measure the effect of each change before making broad reductions. Mention understanding usage drivers, metrics cardinality, log volume, retention, indexing, sampling, custom metrics, data tiers, tagging discipline, dashboards, and optimization without sacrificing critical visibility. Question 11. How would you build a compelling Datadog product demonstration for a technical audience? I would avoid a feature tour and build the demo around the customer's highest priority incident or workflow. For example, I might start with an SLO breach, move from a monitor to a dashboard, jump into a trace, inspect correlated logs, and show the responsible deployment. I would explain why each step matters, invite technical questions, and keep the environment realistic. I would close by mapping demonstrated capabilities to success criteria and proposing a focused proof of value. Focus on discovery-led storytelling, a realistic architecture, one end-to-end incident, measurable outcomes, live workflows, audience participation, controlled scope, and a clear next step tied to the customer's evaluation criteria. Question 12. How would you handle a proof of concept for a large enterprise adopting Datadog? I would define the proof of concept around a small number of measurable hypotheses, such as reducing mean time to resolution or improving service coverage. We would select representative services, agree on data boundaries, involve operations, developers, security, and procurement early, and establish a deployment plan. I would track baseline and post-implementation metrics, document issues and adoption feedback, and hold regular checkpoints. A successful POC ends with evidence, known gaps, and a practical production rollout plan. Discuss hypothesis-driven scope, representative workloads, stakeholders, success metrics, security review, deployment plan, timeline, adoption criteria, risks, documentation, and an objective executive readout. Question 13. How would you integrate Datadog with a customer's incident management and collaboration tools? I would start by understanding the customer's incident lifecycle and existing ownership model. Then I would configure native integrations or webhooks to route alerts by service, team, and severity into the appropriate paging and collaboration channels. Notifications should include monitor context, affected tags, dashboards, and runbook links, while deduplication prevents duplicate incidents. I would test escalation, recovery, and acknowledgement behavior with realistic failures. The integration should support the process rather than create another unstructured stream of noise. Mention webhook or native integrations, routing by service and severity, notification content, deduplication, escalation policies, incident commands, bidirectional updates where available, testing, and auditability. Question 14. How would you address security and compliance requirements when deploying Datadog? I would begin by classifying the telemetry and identifying prohibited fields, regulated data, and regional constraints. Access should use least privilege, separate API and application keys, controlled roles, and rotation procedures. I would review encryption, network connectivity, retention, log redaction, auditability, and account-level permissions with the security team. Sensitive payloads should be excluded or scrubbed before ingestion. I would document the design and validate it against the customer's compliance requirements before expanding coverage. Cover data classification, least privilege, API and application keys, encryption, network paths, redaction, access controls, audit logs, retention, regional requirements, and coordination with security stakeholders. Question 15. A customer already uses several monitoring tools. How would you position Datadog without dismissing their existing investments? I would first understand what each existing tool does well and why teams depend on it. Then I would map gaps such as fragmented context, duplicated administration, inconsistent alerting, or slow investigations. I would demonstrate Datadog against one important workflow and compare time to detection, diagnosis, and response rather than making unsupported claims. A phased coexistence plan may be appropriate, with clear migration criteria. Respecting existing investments builds credibility and produces a more realistic adoption strategy. Be sure to acknowledge current strengths, identify fragmentation and workflow costs, compare capabilities objectively, propose coexistence or phased migration, and define evidence-based criteria for consolidation decisions. Question 16. How would you explain logs, indexes, archives, and retention to a customer designing a logging strategy? I explain that receiving logs and making every log immediately searchable are different decisions. The customer can index high-value operational events for fast investigation, while routing lower frequency or compliance data to archives with longer retention. Exclusion filters and processing pipelines can remove noise or redact fields before indexing. Retention should reflect incident response, audit, and regulatory needs. I would test common queries and recovery workflows, balancing search speed, completeness, storage cost, and governance. Discuss ingestion versus indexing, searchable versus archived data, retention periods, rehydration, exclusion filters, compliance needs, query performance, cost, and selecting data based on operational purpose. Question 17. How would you use Datadog to monitor a Kubernetes environment? I would establish visibility from the cluster and nodes through namespaces, workloads, pods, and containers. I would monitor resource saturation, restart counts, pending or unscheduled pods, deployment health, kube state metrics, and control plane behavior where available. Container logs and distributed traces would connect platform symptoms to application impact. Consistent tags such as cluster, namespace, service, and version enable filtering and ownership. I would alert on user-impacting conditions, not every transient pod event, to avoid noise. Mention cluster, node, pod, container, workload, and control plane signals, Kubernetes state metrics, logs and traces, labels, deployment correlation, resource requests and limits, and actionable alerts. Question 18. How would you monitor a serverless application with Datadog? For serverless workloads, I would monitor invocation volume, duration, errors, throttles, concurrency, cold starts, and downstream service performance. I would correlate function logs with traces so a slow API request can be followed into the specific invocation and dependency. Because instances are ephemeral, traditional host monitoring is less useful. Platform metrics and request context matter more. I would also include queue depth, retry behavior, and cost indicators. Alerts should distinguish transient startup effects from sustained customer impact. Focus on invocation rate, errors, duration, concurrency, throttling, cold starts, downstream dependencies, distributed context, log correlation, cost signals, and alerting around business impact. Question 19. Tell me about a time you handled a difficult technical customer objection. In one engagement, a customer objected that adopting another platform would increase operational complexity. I acknowledged the concern instead of immediately defending the product, then asked which teams and workflows created the most duplication. We mapped their incident process and built a small demonstration showing one investigation across infrastructure, traces, and logs. I brought in a product specialist for an open integration question and documented the migration steps. The customer approved a limited pilot, and I learned that credibility comes from solving the objection, not overpowering it. In your answer, use a concise star structure, demonstrate listening and empathy, clarify the underlying concern, provide evidence, involve experts when needed, and explain the outcome and lesson learned. Question 20. How would you prioritize competing requests from sales, customers, and internal engineering teams as a Datadog Solutions Engineer? I prioritize using customer impact, urgency, strategic value, likelihood of repeatability, and effort. A production blocking issue for a critical customer usually outranks a cosmetic demo request, while a reusable integration pattern may deserve priority because it benefits many teams. I clarify deadlines and dependencies, communicate trade-offs early, and maintain a visible action plan. When priorities conflict, I use evidence and involve the appropriate manager rather than making silent assumptions. Reliability and trust matter more than appearing busy. Mention customer impact, strategic fit, urgency, deal or adoption risk, technical effort, dependencies, repeatability, transparent communication, escalation, and maintaining quality while managing several engagements. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.